Good afternoon for everyone. Thank you for your kind attention, Professor Darko. First of all, I would like to express my deep and sincere gratitude to the Department of Public Works and Highways and JICA and the University of the Philippines for your cooperation in organizing this seminar event today. Thank you so much. And also, I thank you for you all coming here today, watching Zoom. Thank you for your time out of a busy schedule. I'm very excited and delighted to be here in front of you today to introduce our these two technology in the Philippines. So my name is Shota Yoshida from Daisho Corporate, a company from Japan. And the purpose of the presentation today is letting you know about this technology for the slope protection work while preserving the natural environment. So let me begin the presentation with the introduction of our company. We Daisho specializes in slope protection work in Japan, and we pride ourselves on our ability to handle from construction to construction management. We pride ourselves on our ability to handle from construction to construction management and to these kinds of 3D measurement and designing for slope protection work in-house. And we have been conducting JICA survey project from this April, especially in the Cordillera administrative region. And the reason why we have been conducting JICA survey project in the Philippines because Japan has a history of facing and overcoming the challenges on slope disaster prevention similar to those of the Philippines. So I believe that our know-how will be useful in the Philippines in solving the problem that you are facing now. This is our JICA survey team. Our survey team consists of 4 companies, Ironlight Consultants, and CTI Engineering International, and Shiga Bank, and we, Daisho. Today, on behalf of this team, I am speaking in front of you. So let me introduce our technologies. Today, I'm going to introduce these 2 technologies. So the one is called Unit Net method, and the other one is standard method, the special drilling method, and we call it SD method. So the combination of this technology allows us to minimize cutting slope and minimize cutting trees, and it provides us a green approach to protect slope. Generally speaking, in Japan, the slope disaster prevention work or mitigation work can be largely divided into 3 categories. So the smallest one is the erosion control or erosion mat or vegetation mat to prevent the surface erosion. And the largest one, it could be the ground anchors to prevent the deep-seated landslides. Our technology is targeting this medium size of the construction scale. Maybe this is called active protection system for unstable slope, multi-pipe to rail. We are targeting this scale of construction. And you may know this concrete lattice beam. This is a very traditional way to protect slope in Japan. and this is a very effective method. But as you can see, this method has to cut down trees and cut slope. So the unit net is treated in similar to this category, and depending on the site condition, if the unit net can be applied on the site, and we want to keep the scenery, and when we don't want to cut down the trees, we can apply it in the site instead of this kind of traditional work. So I'm introducing the unit net further. This is the concept of unit net. So the unit net is, and this is the actual material of unit net. So unit net is not used alone. The unit net is used with a combination with anchor or long bolt. We call this anchor, but this is not a ground anchor. So this is a lock bolt or soil nailing. Sorry, I'm not sure what this anchor called in the Philippines. And also, bearing plate is used for the vessel. The combination of these kind of material, the unit net can transmit the tensile strength by this anchor to the entire slope to protect slope. And this is the picture of a completed site covered with unit net. So you cannot see the unit net completely because this unit net was installed directly on the natural slope. So during the construction, we don't need to remove these leaves and vegetation. And this leaves works for preventing surface erosion. And not only that, but also we can cut the construction period and construction cost because we don't need to treat the ground surface or cutting tree. And this is an example of unit net. The unit net, 9 pieces of unit nets are provided as one set like this. And you can deploy the unit net easily on the slope. And please show the construction site in the video. As you can see in this video, the unit net can be deployed very easily, and this material is very lightweight, so you can carry on the slope, and you can deploy it like this. And if there are the trees, you can enclose the unit net. And this is the simple assemblies of unit net. So similar to other construction methods in item 5 to 2A, this unit net is composed of unit net and deformed reinforced bar and grout and spacer and bearing plate and head cap. And the lower and upper bearing plates are installed to stand with the unit net and are fixed in place with nut attached to the steel bar. And this is the diagram of unit net. So unit net is 50 centimeter square shape, and we can easily open and close the net with this joint parts. And the steel bars or anchor or nails are typically arranged in a staggered pattern with a pitch of 2 meters pitch or 1.5 meters pitch. So maybe you hit upon the question. So if there's a large tree larger than the space of unit net, so we can encircle the trees with a collective stranded wire rope and connect to the surrounding unit net with specific coil parts. So this is the example there. If there's a larger tree than unit net, in a red circle, the unit net the tree is surrounded by the collective wire ropes with surrounding unit net. So it doesn't matter if there are large trees on the slope. So let's see the construction records of unit net. So this construction site, the slope on the lower part of the slope is composed of rocks. So in this side, the wire mesh is installed first under the unit net, and then unit net is installed on the wire mesh. So the unit net can be used with a combination with a vegetation mat or wire mesh, depending on the site condition. This is another example. As you can see, the tree remained after the construction, and the slope is remained naturally now as it is after the construction. And this picture, maybe you cannot see where the unit net is. Behind this house is this area of the slope is covered by unit net. And even if the site is narrow this much, we can install the unit net to protect slopes. And because not only unit net protect the slope, but also can protect and keep the scenery and natural environment. This unit net is used in this kind of historical place or in an area of World Heritage. And this is a famous temple in Kyoto. In the area of this temple, the unit net is constructed like this. And this is another World Heritage in the Nara Prefecture. And this is an interesting example after the typhoon and heavy rain. So the upper part of this area is covered by and reinforced by unit net, and this area is not reinforced by unit net, and this area failed after the heavy rain. And this is a picture of another angle, and so the area is not reinforced by unit net. Unfortunately, failed like this. So let me review the applicable conditions of unit net. So strong slope is suitable for unit net, and most importantly, the depth of slip surface is not beyond 3 or 4 meters deep. So if the slip surface is deeper than this depth, so the ground anchors or other method is suitable for the case. If the site meets these conditions, so even if the site is narrow or it is required to keep trees or vegetation and scenery, so we can handle it with unit net. And this case is with no applicability or not feasible for unit net. So if the slope is composed entirely rocks, so the site is not feasible for unit net. And the slopes very steep, almost vertical cases is also not suitable. And as I told earlier, so large scale slope clear or deep sheeted landslide is not suitable for unit net. And this is cost difference. This cost difference is the cost in Japan. So I just translate the cost to Philippine peso directly. So this cost is Japanese labor cost and Japanese material cost. So about 13,000 to 15,000 peso per square meter. So let me introduce the other method called standard method, SD method. So as you can easily imagine, unit net is installed without cutting down trees. So drilling for this anchor must be also performed without tree cutting. So this SD method makes it possible to drill the slope without cutting trees. By controlling the drill machine using wires connected to electric winches, it is possible to drill the slope between trees. So this is a typical typical construction site for drilling the slope or solidifying or solidifying. So the temporary scaffoldings and the crane are necessary to put this kind of boring machine on the scaffoldings. And also, traffic restriction is required to proceed construction. I'm not familiar with the situation in the Philippines yet, but in the Philippines also, I think like this situation. So this is the concept of SD method. This video is written in Japanese, but I did not intentionally translate this Japanese to English because it's very clear what this figure wants to say. Because this machine can stand by itself with these supported by two wires, and there are no need to make scaffoldings here. And we can minimize the traffic restrictions when we drill the slope, and we can this method can keep the scenery and natural environment like this. This is a drilling movie. This machine is very lightweight but powerful drilling capability. So, standard method, SD method is not require cutting trees, cutting slopes, scaffolding, cranes. And it's possible to drill the slope even if the site is behind houses, the site is narrow, and even the site among the trees. So we have two types of SD drilling machine. The left one is SD machine type 2. This machine is pneumatic drive one, and the whole diameter of this machine 45 to 65 millimeters, and the maximum effectively drill length is 5 meters each front, and the weight is 150 kilograms. And this weight is supported by winches and 2 or 3 persons. And this orange one is SD machine type 3. This is pneumatic drive and more high power machines, and the weight is 200. It is also supported by winches. And whole diameters are relatively a little bit larger than type 2, the 65 to 90 millimeters, and the maximum drilling length is 7 meters. This machine may look very simple, but this is a result of 20 years improvements in the Japanese construction site. So this, by controlling the wire skillfully, the machine can stand on its own to have a reaction force to drill the slope. You can drill the slope among these trees. And because there's no scaffolding, you can drill the slope even if the cultural site like this. So now we have been trying to introduce this technology in the Philippines. So let me share our survey progress today. So first, we have a consultation meeting with PRS and get meaningful advice from them. And we visited DENR MGB car and DENR EMB car. And they also gave us very fruitful advice to proceed the project. And from the support, thanks to the support of DPWH car, we visited several sites in the Benguet province in Baguio City. And we also get meaningful advice from the Professor Zarco from the University of the Philippines. In the JICA survey project, we decided this pilot site in Benguet province. So, to construct this site with our technologies, I submitted the proposal to JICA. So, if JICA accepts and we can move forward to the next step, the pilot site will be constructed like this. And this site is in the World Heritage Forest area in Nara Prefecture. And from afar, you cannot even see where the Yunicnet net is, but if you come close, the Yunicnet net is certainly there and is reinforcing the slope beneath the vegetation. So the combination of these technologies provide us a green approach to protect slope while preserving the nature. So I understand that our method is categorized into some categories in the blue book. So I think this method could be categorized in item 522A. And because the Yunicnet net, the shape of the Yunicnet net is certainly square, but the tensile force of this, the tensile strength of this net can be evaluated in a similar way, to that of ordinary wire rope. And the tensile strength of this material meets the demand of the wire rope used in this category. So I hope that we can introduce our materials practically on site, and if our implementation on the site can be achieved, the Philippines embraces a green approach to protect landslide. Thank you again for your time today and your kind attention.